And it says we're live. How you doing, John?
Good. How are you? It says my connection's unstable.
Uh-oh. Well, we
So
do the
heads up.
local. Yeah, we'll do the local recording, and hopefully everything will work out just fine.
Jesus, this Rogers crap. Rogers is crap out here. Anyways, how are you, Craig?
I'm doing great. We might as well jump into it. Welcome back to Silicon Scoop, everyone. We got a lot to talk about again this week, and we might as well kick it off. Oh, hang on. My monitor just kind of kicked in over here. In the rapidly evolving landscape of artificial intelligence, Google Gemini Robotics represents a leap forward in merging AI with physical capabilities. This revolutionary technology is transforming how robots interact with the world, bringing us closer to a truly versatile and intelligent machines capable of handling complex tasks without specialized program. What do you think about this? Oh, programming. What do you think about this, John?
I like this because to me, this is the logical next step in robotics. So it's called the Vision Language Action VLA model, which is obviously, like you said, designed to bring AI into the physical world. So typically, robots, for those of you that don't know, traditional robots are limited by rigid programming and inability to adapt to changing conditions, whereas these Gemini robots are potentially able to offer flexibility and real-time learning. Unlike Elon Musk's fake robot display that he did, this is kind of that step. So they're interacting. They're able to understand and respond to natural language commands. They've got dexterity, which enables precise manipulation of objects. They allow robots to handle new objects and new environments on top of what they were originally. So they're a learning robot, right? What do you think?
I think this is really cool because it is programmatically a leap forward, because up till now you had to use special programming languages and robots were designed for a specific task, and not to necessarily do anything other than that. Now this vision language action model changes things because of its awareness of space and structure, and it tells you what it's doing. It describes its rationality for doing it. You can interrupt it and get it to do other things based on, wait a minute, let's think about this, and interact with it, get it to ask you questions. It responds to different surfaces, whether things are heavy or light. It balances things based on liquid. And it does these things kind of automatically rather than programmatically now, which allows people to focus on what the task is at hand, not necessarily how much pressure, how to move the arm, all that kind of stuff.
Exactly. Yeah. So this is great because they're able to adapt in real time, and this could enable robots in the house to help out with household tasks. And I know there were a couple. I think there's a company that's looking to sell robots into the home in 2025. I can't remember the name of it. I don't know if we covered it, but this is good. I think this, along with if you integrate I don't know if you saw that creepy video of the artificial muscle robot twitching, but yeah, if you integrate that with this, then you've got your iRobot essentially, right?
That looked like a failure from Westworld, that twitching robot. It looked like one of the early models that didn't make the cut. If you're watching, these are various videos from Gemini Robotics demonstrating skills and what it can do. This one is really cool. Pay attention. It's origami. Or they do origami. This one's doing glasses. So Gemini powered robots can adapt to unfamiliar objects of various shapes, sizes, and materials, navigate and operate in new environments without prior mapping, apply learned skills to unfamiliar scenarios through reasoning, perform tasks ranging from delicate precision to heavy lifting. It uses natural language commands and multiple language visual demonstrations that the robot can observe and learn from. So you can, demonstrate how you can communicate with it. You can talk to it. You can show it visually. real-time adjustments during an ongoing task. You can say, wait a minute, this and that, put the fork on the left, whatever. And conversational feedback. So this is really interesting. We're getting unprecedented dexterity, fine motor control, complex sequential actions such as tying shoelaces, dynamic force adjustments when handling fragile items, coordinated multi-digit manipulation, similar to human hand. So like we're really talking about advanced stuff. And what really makes this capable is their Gemini Robotics and ER, which is enhanced spatial and embodied reasoning, which includes superior spatial awareness, enhanced trajectory planning, physical constraint reasoning, and adaptive grip control. Things like you can it grabs a mug by the handle if there's a handle.
Yeah. My biggest concern. So obviously, it's got the ability to generate actions without human supervision. My biggest concern is the hackability of these, because everything can be hacked, and so that's my biggest worry about these things. That, and obviously the potential misuse from the hacking or without hacking, right? So do we need to integrate what was the US Robotics, the three laws or the 3 rules or something?
Yeah, Isaac Asimov's 3 rules of robotics.
Yeah. Is that what we need to do? Do we need to make it more extensive? What do you think?
Well, they talk about it, and let me switch over to the Toronto Star's article here instead of the video you were seeing. So they talk about it a little bit. I'm trying to find it. Safety and ethical concerns. The Asimov data set for social validation of robot action. So this is what's been included. The built-in constraint system that prevents harmful movements, continuous human oversight during development and deployment, and explainable AI features that allows robot to communicate their decision-making process about what they're going to do. So physical privacy concern, protections when robots operate in sensitive environments, transparency about the robot's capabilities and limitations, and considerations of economic impact and responsible deployment, and ensuring human control remains the ultimate authority. So these safety measures reflect Google's commitment to responsible AI development and may address some of the concerns, but
And for those of you that don't know, the 3 laws are: the first law is no harm. So a robot may not injure a human being or through inaction allow a human being to come to harm. Second law is obedience. A robot must obey the orders given it by human beings, except where such orders would conflict with the first law. 3, the law of self-preservation. A robot must protect its own existence as long as such protection does not conflict with the first or second law.
Yeah, and we'll see. We know that AI often goes off the rails. And when you're chatting with it, when you're doing different things, when you're coding, so we've seen the horror stories of the kind of stuff it tells you, when it tells you to go, end yourself and that kind of stuff. What happens when that kind of glitch happens in a robot that physically could do you harm?
Yeah.
So yeah, there are definitely concerns around the future of robots. However, that is around the whole future of robots thing, like especially when you talk about things like Boston Dynamics, who they've got robot security dogs and armed and whatnot. So it's not they're designed to harm things versus so where do you draw the line, right? And if an AI is designed to harm things, or maybe it's not AI but it should be probably at this point, differentiating the two and getting into program. And we all hear the stories about how OpenAI lied to itself, replicated itself, tried to get itself out. So if that kind of stuff is happening, we should be concerned.
Yeah, I agree, and we should be concerned about the people building them. No offense to those who are ethical, but there's going to be non-ethical people who are going to get involved in building these things. And how do we ensure that these robots are are going to adhere to these laws and all this sort of stuff. Like there's a lot of future implications that need to be considered, and I hate to say it, but a lot of regulation.
Yeah, well, we're seeing it, right? We're seeing the world move to this, and the question becomes: the military is adopting AI. We've seen it. There was a recent demonstration of infrared AI drones that took out an F-16.
Yeah,
And like it's the capabilities are going there, right? So there is going to be military applications, end of story. So you're talking about putting rules in place that people and countries in certain aspects are going to deliberately break because it's there.
yeah,
Maybe maybe that's a good thing, because maybe a robot is better to have a robot destroyed than a human life.
exactly.
But you're right. A lot of implications have to do around this to make sure that things don't go awry. But we're looking at that future, that the Jetsons and whatnot, everyone having a robot in their home.
Yeah, we're getting there. We're close. Like there's going to be robots in homes. I think this year. Correct me if I'm wrong, listeners and Craig. I think I read an article that there's going to be robots in people's homes this year.
That is what's supposed to be happening. I don't know how complex those robots are going to be. We see all different types of robots. I've recently seen those dancing and ninja looking robots who are jumping around, kicking in the air and dancing and stuff, like crazy capabilities. So the journey of Google Gemini Robotics is just beginning, but it already signals fundamental shift in how we think about automation. Rather than programming robotics for a specific task, we're entering an era where robots can understand our intent and translate it into appropriate actions. A true collaboration between human ingenuity and machine capability. So let me know, are you going to be the first to line up to get a human that'll carry in your groceries, run your bath, do your vacuuming, do your dishes, rather than a robot to do your coding? Let us know what you're going to use your robot for. We'd love to hear your comments. In a world where rising temperatures and climate change concerns dominate the headlines, a groundbreaking zero-emission cooling technology has emerged from the Hong Kong University of Science and Technology, or HCUST. This innovation promises to transform how we think about keeping cool without harming our planet. What do you think of this, John?
Yeah, this is cool. So I actually was it a few years ago, I was researching just because I was bored on magnets and how they could potentially cool. And so this is cool because HCUST have developed. So what they did was they developed the world's first kilowatt scale elastocaloric cooling device. So it's a solid state cooling technology, and they were able to stabilize indoor temperatures at a comfortable 21 to 22 degrees Celsius in just 15 minutes, even when outdoor temperatures reached between 30 to 31 degrees Celsius. And sorry for those of you in Fahrenheit, I don't know. The technology relies on what's called shape memory alloys, which specifically the makeup is nickel titanium tubes, which what they do is they release or absorb heat when they're compressed or stretched. So this is cool because if they can scale this, the approach will eliminate the need for refrigerants with the high global warming potential. So this could offer a zero emission alternative to these traditional air cooling systems, and could enable, because I know with traditional air cooling systems you need an exhaust. Maybe you don't with these. I don't know. What do you think about this? Do you think this has potential, Craig?
Well, the global demand for air conditioning continues to surge at an alarming rate. Everyone talks about whether it's global warming or climate change or extreme weather or what have you. And as I get older, I seem more sensitive to the heat and to the cold, so we want a little bit more. But current cooling systems consume approximately 20% of electricity worldwide.
Crazy.
So making this a significant contributor to carbon emissions. This problem is compounded by the use of what, you mentioned, the hydrofluorocarbons, HFCs, in traditional cooling systems, which have a global warming potential thousands of times greater than carbon dioxide. So considering these sober facts, air conditioning use is projected to triple by 2050.
Yeah.
Cooling related emissions could potentially rise by 90% from 2017 to 2050. So 90%. Current cooling technologies face major efficiency limitations, and many regions experience rising temperatures, a lack of affordable cooling solutions. So it's more and more, it's going to become important. I'm really excited about this solution. And I'm curious to dive into a little bit more.
Yeah, so let's dive into it a little bit more. So they overcame previous limitations by designing the SMAs in series, and the fluid in parallel, which is considered a multi-cell architecture. So just to break it down, the design connects 10 elastocaloric cooling units in series, which each contain 4 thin-walled nickel titanium alloy tubes. Now, the tubes themselves, they feature a high surface to area volume ratio, which significantly improved the heat exchange efficiency. Now, on top of that, and this is where we've talked about this before, they're using graphene nanofluid as a heat transfer medium, which conducts heat 50% more efficiently than distilled water. So they've nearly tripled the previous record for liquid-based elastocaloric devices. So I don't know where they need to get in order for it to be feasible. It sounds like it's feasible now. My question is, and I didn't look into it, but I'm curious as to what the energy usage of this system is. Do you know anything about that? Did you find it anywhere?
I'll take a look as we're going through it.
Yeah.
But the system delivers an impressive 1284 watts of total cooling power, making it the first kilowatt scale elastocaloric caloric cooling device ever developed. This represents a quantum leap in capability compared to previous laboratory prototypes, which typically, a few dozen watts of cooling or up to 260, which just doesn't quite do it.
Yeah, so
Like
it says that. Oh, go ahead.
No, you go ahead. You got the answer.
No, it says that not only does it eliminate the harmful refrigerants, but apparently it also offers more energy efficient cooling solutions. So it is more energy efficient. I just don't know how much more.
Yeah, carefully optimized tube geometry that maximize surface area while minimize material volume, strategic parallel, and precise mechanical loading mechanisms that apply uniform stress. I'm trying to see the sub-zero cooling for refrigeration and food preservation.
I don't think they've released it, yeah.
Thermal management systems for electrical vehicles. Heat pump applications for renewable energy systems, industrial process cooling with strict environmental controls.
Yeah.
So I haven't seen specifically what the energy reduction is.
Yeah, but and I'm curious to know, are they at a point where it's feasible to? And again, you probably don't know the answer to this, but these are just questions that pop up. Is it at a point where it's a technology that is ready for consumer use, or is there still more, based on current usage of greenhouse gases or for coolants in air conditioners and the lack of efficiency? Based on this preliminary, is it ready? It sounds like it is to me, but I don't know. Maybe there's commercialization, production issues, things like that, right?
Yeah, we're gonna start seeing this soon. I'm trying to figure out where, because they mentioned no, that's the end of the article here. So it's reduced electricity demand. These things are supposed to be 50% more efficient. So if that is energy efficient, great.
Yeah.
And they got that by adding the graphene to the water.
Yes, no, just a whole new. It's a graphene liquid, graphene based liquid.
Yeah.
Graphene nanofluid. Sorry.
Yeah, there it is. Graphene nanofluid. Yeah. So that boosted the thermal conductivity by approximately 50%, but it said overall the system is about 50% more efficient. So
Okay. Yeah.
So that would be a huge benefit to us. Plus, the lack of emissions makes this fantastic green technology. So, if it's 86 to 88 degrees outside, which is 30 or 31 degrees Fahrenheit, this is able to get a room down to 70 to 72 degrees within 15 minutes. So it's actually feasible to use this for air conditioning in the home and stuff now.
Yeah, let's hope I can get it down to like 16, 17. I like it there when it's hot out. So,
well, you might have to add a ceiling fan or something.
Yeah, or maybe get two of these, and then at least I won't have any coolant. It'll just be less energy efficient, but we'll see.
In a world struggling to balance increased cooling needs with urgent climate imperatives, this zero-emission cooling technology offers a promising direction for sustainable thermal management, one that could help cool our built environment without further heating our planet. Let us know what you think. Is this a technology that'll be around soon and you are standing in line waiting for one? Or is this another one of those pie in the sky things that we're not going to see for a bunch of years and you're not waiting for this? Let us know what you think.
Jeez, you're jumping all over the place today.
These are just where the tabs were when I put them together. All right. Is that right? I got that. Yep. All right. Let's go ahead. The high stakes race for dominance of everything apps pits Sam Altman's world against Elon Musk's X as these titans battle for a position that could reshape how billions engage with digital services. The implications reach deeply into our everyday online interactions. So what do you think about this? Again, Sam Altman and Elon Musk are at odds on something new.
I love it. Yeah, I love it. I don't see obviously I don't use WeChat. So this is just to give some people context. So Sam Altman's got this startup called World. And I think it's the same startup that is scanning your irises. I think that's that. And I could be wrong. So please, guys, feel free to correct me. But it's looking to challenge, because Elon Musk said he wants to have an everything app. So they're developing a super app ecosystem that includes everything like payments, chat, microloans, and it's all verified through a unique biometric method. And involving iris scans. That's right. So yeah, so this is part of that iris thing. So this is, for those of you that use WeChat, it's like an all-in-one. It's a one-stop. You just go do everything in the app. You play games in the app. Your social media is in the app. So you do all that sort of stuff. I believe Sam Altman, other than the iris crap, which I don't agree with, I think he has a great idea. I think Elon is screwed because he's trying to develop an app based on a platform that people are leaving. What do you think about that?
Well, so Sam Altman's world appears to utilize OpenAI's advanced AI technology as its key differentiator. So, it's an AI-powered experience using users delegating tasks to AI agents tailored to their preferences. So Elon Musk is looking at payment solutions to X, video solutions. He wants to be YouTube, wants to be everything.
Yeah.
I think there's room for lots of competition in this space. I take a step back and I wonder where, outside of this, the lawsuit that Musk has against OpenAI about it going from a non-profit to a for-profit organization. I think there's going to be something going on there, but I'm not exactly sure what the output of that's going to be. Because obviously Sam Altman's world has more access to OpenAI and potentially unfair access to those things if we're
Yeah.
going to be honest about it. Does that matter? I don't know.
Yeah, does it
You
matter
say,
though? Because this isn't OpenAI. This is World, and he's got a lawsuit against the OpenAI, right?
yes, agreed. But again, they're competing on another thing. So is OpenAI a for-profit or a not-for-profit? Or this is the thing, right? Are they a competitor to all these other things out there? Because they all originally invested in it thinking it was a not-for-profit and we're going to help and share this knowledge. But all of a sudden they're blurring that line and they're not sharing all the knowledge and it's not all open source. And someone like Sam Altman is going to leverage it and use it for his thing. And I don't personally, I think companies need to make money to survive. I don't necessarily have a problem overall with the concept of profit versus not for profit. I'm going to set that aside in a minute. I just don't know where that's going to go and what that means.
Yeah.
Because, government and other people funded it based on certain expectations that have changed. So what does that mean? And obviously from a cooperative environment, changing the AI to a competitive environment. All I'm saying is when we look at FTC rulings recently about unfair advantages, I look at this and say, okay, well, Sam Altman looks on the surface to have an unfair advantage leveraging OpenAI's technology to build his other startup because he will have access to those tools and things that other people will not have access to.
Yeah, but Elon has access to Grok, which is good.
I'm just saying that do other developers building apps out there in the world? It's not an Elon versus Sam thing. It's
Well, this is a whole different discussion than this platform. This is
I just saying it's the same thing. Is it competitive or not competitive? And once you start getting this information and they start controlling your payment, your biometrics, and who you are, when do we start worrying about monopolies and these things? I think it's the same conversation just because they bleed into each other from are they using these? Is it an open source platform or is it a private platform that you're using to take our information, our biometrics, all our stuff to power this? Where's that information going? Who gets to use that information? I think there's lots of discussion around the back end stuff for both of these. That aside, I love the competition on this area because we have dozens of apps on our phone and whatnot, and probably only use 4 or 5 on a regular basis. I'd be curious to know what the stats are, how many apps are on your phone that you don't use it in the last 6 months, as an example. So when you have an app that is your payment app, that is your news app, that'll do your social media, then you're starting to, not come out of this one thing. Now, your original question was everyone.
Sorry, I lost internet there.
Yeah, your original. I just kept talking. Your original question was, does Sam have an potentially unfair advantage with everyone leaving X's platform?
No, I didn't say that. That wasn't my question.
You didn't say unfair advantage. Sorry. Did you think that Elon Musk has a chance against this because people are leaving his platform? Is he going to be competitive? Yeah. Sorry. My apologies. I wonder about that. First of all, Sam's got to start from scratch. There's not many, if anybody, on World right now because it's not out. So how does that get integrated? How does he build that up? What happens there? Yeah, I think, people leaving X, people are going to leave for a while. They're going to come back. This has all happened before. So
I don't know. Based on what Elon's doing, I don't know. We'll have to see. But anyways, you and I don't share the same opinion of that. But
yeah, well, this becomes a whole thing. It's political, right? So if you don't like what Elon Musk is doing, get off his platform and go somewhere else. People are thinking, I'm going to go here. I'm going to go there. Go to Blue Sky, sure, but you're not going to get the reach. You're not going to get the same thing. So the question becomes is a lot of people left and they come back. A lot of people say X is too toxic. They go over there and say, oh my God, this is even worse. Some people say it's a paradise. So the point being is I remember Clubhouse was all the rage. It was going to blow everybody away. And I'm sure it's still functioning now. I'm not sure it's still functioning now, but I thought I saw somebody hosting a Clubhouse recently, but it dropped off into obscurity really fast.
Yeah.
And so has almost every other competitor of X's or Twitters in the past. Like people are using Threads, but are they really like what's the percentage of people using Threads?
Yeah, that's true. Yeah.
So I sit back and I say, okay, people tried to go to there was an open source one that was the Fediverse, where it was federating all these I can't remember. And that
Okay.
became too hard. I have an account on that, but people went there and then, oh, it doesn't do quote tweets or retweets the way I like, or doesn't do this the way I like. And eventually they come back. And so it becomes a, if this is the most popular platform, it's going to be hard to compete. So I think, even though people are leaving, I think they're actually at an advantage unless somehow Sam Altman deploys to gives it away free to all OpenAI clients or something and gets, somehow that
Oh, I'm
way.
sure. Yeah.
You say you're sure, but those are separate entities. That's why it becomes a thing. Like this
Yeah.
is why X
Okay.
is building it on X. They already have a thing. That's why I'm like, oh, okay. Then we go back to, are you a for-profit or not for profit? Because you took this money, then you made this thing, and now you're competing with the people you took your money from. That's all I'm saying is it might shake out to be a little bit different than, and what this might mean that maybe somebody gets more ownership or doesn't, but it's silent partnership and it's this and it's that. It's all going to work out. It's nothing's going to get stopped. I'm just saying that there's a bigger stuff here. So world's potential advantages, advanced AI integration capabilities. But like you said, Grok is coming back, but Grok is, OpenAI is the whole AI company doing all these agents and stuff. And though Grok is leaping ahead and everyone's loving it, I don't think it's going to scale to the level of OpenAI will.
Let me throw a wrench into this whole argument.
Sure.
Because there is another platform that has multiple apps that people are engaged in that we haven't even scratched the surface on. What about Meta? Do you think Meta has a chance against these other two if they were to develop a super app? It would make sense because they've got WhatsApp, they've got Instagram, they've got Facebook, they've got Threads, but like they've already got a bunch of apps that they could integrate into one. All they need to do is add payments and the other stuff. What do you think?
I think if they could do end-to-end encryption, then they could add a bunch of microservices on the back end and feed this to all their applications.
WhatsApp has end-to-end encryption.
No, that's one thing. My point being is, if you wanted to truly make this something interesting, from a Facebook point of view, you would make the functionality available in Facebook, in Instagrams, in Threads, in all those things. That's all I'm saying is you say, wait a minute, we're this because otherwise you're not the everything app. So it's curious.
But like one app where like it's multiple different, like everything's in that app.
Yeah, my point being is, if you're talking about payments, you centralize that into, a microservice. If you talk about video, that becomes a video microservice. That's why these things become available in all the platforms, because X has got one platform, World is building one platform, Facebook has a bunch. So the question is, would their strategy be to try and build a set of tools that integrates these functionality and all those things so you don't have to choose, or would they build something new? They risk losing their audience. They have a specific audience for Threads, a specific audience for Instagram, a specific audience for Facebook, and they're not all the same. So they have to be a little bit careful about trying to mix them.
True. Yeah.
But they are a potential competitor for sure.
Yeah. For sure.
I don't know if anybody trusts any of these people, but I think if you, except for Elon Musk's political stuff, I think Facebook would be the least trustworthy of Facebook, X, and OpenAI. So that's why I think people would hesitate a little bit around that. But
I agree. Like their data policies are horrific. Meta's data policies, they're absolutely horrendous. We never covered them because they had changed them before we started this podcast, but they're absolutely horrendous.
Yeah, it's crazy how bad they are.
Yeah.
So we'd love to dig in this more. There's some regulatory compliance about GDPR, CCPA, potential antitrust arising from concentrated market power, like we were kind of talking about. There's complex financial regulations everywhere. X has already started with digital wallets and doing payments in, like if you're a subscriber. You can get paid if you get a lot of interactions and stuff on your tweets, and it'll pay for your subscription and stuff. The point, I guess, them is if you have $10 in your Twitter wallet, you'll spend it on Twitter. So I think they have a clear advantage just from people are actively using it every day, and there's currently money in wallets on Twitter.
Yeah, but that can easily be beaten.
Absolutely. I mean, so it's what we would call early mover
if you're taking
advantage.
a snapshot right now, sure.
Yeah, it's what we would call early mover advantage, for lack of a. They're out there, they're doing it. It doesn't mean that once world drops that it won't leapfrog, that people won't, say drop this like a hot potato and jump over there. It doesn't mean any of that. And they may come out with better partnerships with payment providers, with whatever that may just blow everyone else away.
Yeah.
But I question again with any of these companies, what are they doing with our data? How private is any of this? Do I trust OpenAI with my payment stuff when I'm buying stuff back and forth? My personal, where is that information going? Is it going into a public AI database that other people can eventually get at? Same thing with X, same thing with all of them. So, they got to really think about this through. I'm always concerned when a new app is built around an AI system because, okay, how private is that information then?
Yeah, exactly.
Because you're using that interactions to remember, to do different things, to train the system. So how long before people start pulling stuff back out of it?
Yeah.
So we'd love to know what you think. The race between Altman's world and Musk's X could redefine digital interactions in the Western society. The winner may not just set the course for future of everything X, but also reshape how we navigate the increasingly interconnected digital landscape. Do you already have a favorite? Are you waiting for Altman's world, or are you happily trudge along with Musk's S, or is there something else out there? Or you're like, I don't like any of these companies. I'm sticking to cash. Let us know in the comments below.
Altman's world sounds like a TV show, or yeah. Anyways, sorry.
Oh, it does sound like a TV show. Let me change the banner. In a groundbreaking discovery that could transform the landscape of sustainable technology, researchers at McGill University have identified a temperature-independent anomalous Hall effect, AHE, in ultra-thin bismuth. The remarkable finding challenges conventional physics understanding while opening new doors for green electronic applications. The non-toxic and biocompatible nature of bismuth makes it ideal candidate for environmentally responsible electronic components, potentially replacing harmful materials currently dominating the industry. Wow, what do you think about this, John?
This is cool. I love Canadian University McGill doing this groundbreaking discovery. Shout out to Canadians. This, I'm still having trouble wrapping my head around it. Just because of the talk of, they discovered ultra-thin bismuth exhibits mysterious electrical effects, which you talked about, the AHE. So the phenomenon is typically associated with materials having magnetic properties. But bismuth is observing this despite it being a diamagnetic nature. So the ultra-thin bismuth remains stable across a wide temperature range from, this is cool, near absolute zero, which for those of you that don't know is minus 273 degrees Celsius to room temperature. And like you said, it challenges conventional physics, but the potential applications are helpful because it could develop more efficient, stable electronics for space exploration, medical uses, and more green type electronics. So just as a comparison, traditional materials used in electronics, they often exhibit temperature-dependent properties, which can limit their stability and efficiency in extreme conditions. This is why the bismuth discovery could help with specifically space exploration, where it's super, super cold, and medical devices where there's a huge fluctuation. But what do you think? Are you grasping this concept better than I am, Craig?
Yeah, okay. So the anomalous Hall effect typically occurs in ferromagnetic material, where a voltage develops perpendicular to both the current flow and the applied magnetic field. What makes the McGill discovery so revolutionary is that bismuth is diamagnetic. It shouldn't exhibit this behavior at all. Yet, when
Yeah.
reduced to ultra thin flakes of approximately 60 nanometers, the bismuth displays this unexpected property. Even more remarkable, like you mentioned, the effect remains consistent across extreme temperature ranges from, like you said, near absolute zero all the way to 300 Kelvin, which is room temperature. So the temperature independence is practically unheard of in quantum electronic phenomenon, which typically require extremely cold environments to function. The stability across such varied conditions makes ultra-thin bismuth exceptionally valuable for practical applications in sustainable electronics. So hopefully this is going to make qubits more stable in quantum processors.
Yeah.
I love this idea. It was inspired by a cheese grater.
Yeah.
The drawing inspiration from an everyday kitchen tool, the cheese grater, researchers created an innovation approach to producing these ultra thin flakes. The process involves etching semiconductor wafers with precise patterns, mechanically shaving bismuth across these patterns, and collecting and analyzing the results in thin flakes. So it's a game changer for green technology. So,
Yeah.
you can use this in space exploration and medical devices, consumer electronics, or energy efficient systems that generate less heat. And unlike many quantum electronic materials that only function at cryogenic temperatures, this effect persists from near absolute zero to all the way to room temperature. So, which is exciting for people.
Yeah. And the reason why we're talking medical devices, right, is because bismuth is non-toxic and it's biocompatible. So that's why it's an ideal ideal for medical devices. So this is interesting. I guess I was trying to wrap my head around the diamagnetic kind of aspect of bismuth, because I don't know if you know bismuth, like you create crystals and stuff. I don't know if you've seen that from sound waves. So it was hard for me to wrap my head around this, it's cool though. I think this is great. I think there's I hope that research continues. But yeah, this aligns with kind of the broader trend towards sustainable electronics. So it reduces the reliance on materials with high environmental impact, because bismuth has a greener manufacturing process. So really cool stuff, really interesting. Let's hope that they continue this.
Yeah, this is really challenging conventional physics understanding, challenges of fundamental physical assumptions about material behavior. So it's okay, not necessarily to get your head around it right away, because it is complex. And we're talking about ferromagnetism versus ultramagnetism versus I can't remember the traditional kind. Ultramagnetism, the third kind, we were talking about it last time. So
Yeah,
it's interesting to see all this cool stuff and say, all right, we can use these crystal like substance, shave it to a certain thin level, etch some stuff in it, and actually functions like an electronic circuit and it shouldn't do this.
Yeah.
So the QAHE, the quantum anomalous Hall effect, represents a quantized version of the effect that already observed potential offering. So perfect electron transport efficiently with zero energy disposition, quantum computing components functioning at high temperatures, which is unheard of right now, and revolutionary approaches to energy efficient electronics. So this should really help out the quantum computing environment. And it's non-toxic.
Yeah. Let's hope so. Like there's a lot of it, and the cool thing about this is this was completely unexpected, and I think we touched on that. But it's usually the surprise discoveries that that lead to these innovations.
Yeah, I'm really looking forward to seeing where this goes. The discovery showcases several important principles for sustainable technology. Exploring overlooked materials can yield unexpected benefits. Questioning established physical limitations leads to breakthroughs. Environmental considerations could be integrated from research stages, and sustainability and performance can advance together. So hopefully, we're going into a brave new world where we're starting to think about these things before we get into it, like sustainability, energy efficiency, long lasting, how long the world, saving the world, right?
Yeah.
The future is not necessarily with Elon Musk and his robots on Mars. We want the future to be here on Earth.
Yeah, we do. Yeah, and less reliance on expensive rare earth minerals.
Yeah, exactly. This is much more common, less reliance on rare earth minerals, which is great. The ultra thin bismuth discovery reminds us that sometimes the materials and approaches overlooked by conventional wisdom hold the key to solving our most pressing technological and environmental challenges. As we look toward a future of increasingly electronic dependent societies, such sustainable innovations will be essential to balancing technological advancement with environmental responsibility. So are you looking forward to getting this in your phone, in your device, or this is nothing exciting to you and we're still a pipe dream, this type of technology? Let us know what you think in the comments. All right, which one do you want to do?
It's up to you. Dealer choice.
Since we only have one, let's do the mouse.
Yeah, okay. This is cool.
All right, let me.
Cool and scary. Go ahead.
Have you ever wondered what makes human speech so unique? Scientists have been fascinated by the question for decades. Recently, a groundbreaking study put the human language gene Nova1 into mice with remarkable results that shed light on our evolutionary history. What's going on here, John? What do you think of this?
This is cool, but also scary as F. So researchers at Rockefeller University have conducted an experiment. They inserted a human variant of the Nova1 gene into mice. So this is the gene which codes for the protein Nova1, which is it's a neuro-oncological ventral antigen. And I'm sorry if I butchered that. So it's associated with vocalization and language development in humans. So the human-specific variant of Nova1, it includes a single amino acid change from one position to another position at position 197, which is not present in other animals, which includes Neanderthals. So the study revealed that the mice with the humanized Nova1 gene exhibited altered vocalization patterns compared to their counterparts. So baby mice with the human variant produced higher pitched squeaks with different sound patterns when calling for their mothers. And these squeaks were categorized into letters S, D, U, and M. And the humanized mice showed changes in these vocal letters. And then also adult mice also produce more complex high frequency calls when attempting to woo females, suggesting that the variant influences vocal behavior in mice. How crazy and scary is that?
Yes, this provides physical evidence that Nova1 influenced not just vocalization, but actual neural circuits involved in producing sound. Now, we want to be clear that the different vocalizations of adults during the attempted mating did not seem to make them any more successful. So doesn't mean just because they're communicating differently doesn't necessarily mean they're communicating better with their specific counterparts. So Nova1 specifically affects brain regions associated with vocal behavior, including areas that in humans are critical for speech production and comprehension. The gene regulates RNA splicing in a way that influences neural development in these specialized brain regions. The timing of the 197V mutation aligns with the human evolutionary history. It appears after a lineage split from Neanderthals and Denisovans approximately 500 and 600,000 years ago. This time frame corresponds with periods when early humans were developing increasingly complex social structures and tools, suggesting language development may have co-evolved with other advanced capabilities. So what's particularly fascinating is how such a small genetic change, a simple amino acid substitution, could potentially contribute to such significant differences in communication. This aligns with modern evolutionary theory, where a relatively minor genetic changes can sometimes lead to major phenotypic differences, specifically when those genes act as regulators of other genes. So go ahead.
So my question to you is this the first step into enabling animals to talk to humans?
So,
or are their brains not able to handle it?
I think we're going into their brains aren't able to handle it because they don't have the culture, they don't have an art, they don't have the discovery that Neanderthals had ancestral versions of Nova 1, not the human version, not the human specific version, provides intriguing insights about our ancient relatives' communication abilities. This genetic difference suggests that while Neanderthals likely had some form of communication, it may have been fundamentally different from modern human speech. So basically, you know, they were making tools, they were communicating, making art, but they didn't have this particular mutation. So they were able to communicate in other ways. So I think that is what's missing in things like mice, is that they don't have the art, they don't have tools, they don't have the ability to reason, maybe not even society.
Why can't we give it to them?
Well, this becomes a longer story, but I like, kind of where you're going. These discoveries help us understand why, despite their many sophisticated abilities, Neanderthals might have been at a disadvantage compared to Homo sapiens in terms of communication efficiency, social coordination, and cultural transmission. So factors that could contribute to eventual extinction with our ancestors. So beyond these single genes, the broader context of language evolution. So there's several other genes have been implicated in language development. The FOXP2, often called the language gene, mutations cause severe speech disorders. The CNT-NAP2, associated with the language development and linked to conditions affecting communication. The ACPM and the MCPH1, genes related to brain size and potentially cognitive abilities. And the SRGAP2, involved in neocortex development and uniquely duplicated in humans. So these genes don't work in isolation, but function within a complex networks that influence brain development, neuron connections, and cognitive processing. The entire suite of genetic changes, not any single mutation, enabled human language capabilities. So that's where we start talking about, okay, how much of this can we fundamentally change in, say, a mouse before we start to get some of this? So environmental factors and cultural transmission play equally crucial roles. Language acquisition requires exposure and learning within social context. So the human capacity for cultural accumulation allowed language systems to develop complexity over generations that far exceeds what genetics alone could produce. So using the mice as an experimental model has its limitations. While mice produce vocalizations, they lack the neural circuitry for complex language production and comprehension that humans possess. The Nova 1 experiment shows genetic effects on vocalization, but can't replicate the full complexity of the human language. Is this the first step? It might be.
Yeah. So I like this. This is cool, but it also scares the crap out of me. Because this just opens the floodgates, I think. Not floodgates, but opens the doors to testing out with other genes, splicing genes, and adding other genes like the FOXP2. So I'm interested to see what comes next.
Yeah, let's not get into all the ethical and stuff here. There's a lot of stuff going on here, and we're kind of running out of time. So as we continue to explore the genetic basis of language, we gain not just scientific knowledge, but deeper insights into our own nature and the evolutionary journey that shaped our species. The mouse experiments with Nova 1 represent one more piece in the fascinating puzzle of human origins and the remarkable biological foundations that make possible all human culture and civilization.
Yeah.
We'd love to know what you think. Is this the first step for us communicating with animals, with mice, or, developing their cognitive abilities well beyond what they should? Is this the beginning of the end, and maybe we're heading into Planet of the Apes territory? Let us know in the comments below. So what do you got going on, John?
Well, for those of you listening live, this week is NCAA March Madness, so I'm excited. Got all my brackets in. I'm ready to go. But whenever this comes out, I'm sure there's startup drinks happening or just happened. So, but that's then I think we've got Consensus and Futurist coming up. More excited for Futurist, but yeah, how about you?
Yeah, this will be coming out mid-April. Lots of stuff going on. Head over to torontostarts.com and see our latest list of events. Startupdrinks.com, torontostarts.com, or startupdrinksto.com, or startupcoach.ca. You'll see all the stuff that we got going on over on any of one of those websites. Make sure to click on the show notes when you're listening to the podcast. That takes you to a more detailed articles. If you want to deep dive in anything we talked about today, just click that in the podcast. And that's about it. We really love to hear your feedback. Let us know in the comments below, and we'd love to hear from you. Thanks a lot for listening.
Thanks, everyone.